Vamos, carioca, sai do teu sono devagar. O dia já vem vindo aí e o sol já vai raiar. São Jorge, teu padrinho, te dê cana pra tomar. Xangô, teu pai, te dê muitas mulheres para amar. Vai o teu caminho, é tanto carinho para dar. Cuidando teu benzinho que também vai te cuidar. Mas sempre morandinho com quem não tem com quem morar. Na base do sozinho não dá pé, nunca vai dar. Vamos, minha gente, é hora da gente trabalhar. O dia já vem vindo aí, o sol já vai raiar. A vida está contente de poder continuar. E o tempo vai passando sem vontade de passar. Ei, vida tão boa, só coisa boa pra pensar. Sem ter que pagar nada, céu e terra, sol e mar. E ainda ter mulher e ter um samba pra cantar. Um samba que é o balanço da mulher que sabe amar.
Welcome back, everybody. Could we encourage everyone to sit down and prepare for our next set of speakers? If we could. Okay. It's always a sign of a good conference if you can't call order because everyone's so busy networking, or not working, as we should now call it. We now have a clutch of speakers who can only be called global voices. I'm going to be a bit draconian in my approach because we do want to hear properly from all of them. So if you see me leaping around waving fingers at them, I'm not being rude, I'm simply indicating that they only have a couple of minutes to go, or perhaps 3. We hopefully will have time for some questions at the end of each speaker, but if we do run on, we may have to curtail the questioning. The first speaker is Professor Michael Oppenheimer. Michael is the Professor of Geosciences and International Affairs at Princeton. He's a long-time participant in the Intergovernmental Panel on Climate Change, and has served as a lead author on the third and fourth assessment reports. He's currently a coordinating lead author of the IPCC Special Report on Managing the Risks of Extreme Events and Disasters to Advance Climate Adaptation. He's a bit of a media superstar, and he's going to talk today on climate change impacts, especially ice sheets and sea level rise, and the impact on deltas.
Thank you for that overly kind introduction. I'd like to thank our host for inviting me to address this critically important conference. I've long thought that the threat from sea level rise presents the greatest challenge associated with global warming for three reasons. It has a worldwide impact, it involves long lags and irreversibilities, and perhaps most important, we cannot reliably predict how much sea level rise will occur over the long term, nor when, nor can we say if or when our ability to do so, that is to make the predictions, will improve. Largely due, and this uncertainty is largely due to the puzzling role of Earth's major ice sheets in Greenland and Antarctica. The last point, which puts the problem in a special class for policymakers, particularly those with regard to planning for the future of adaptation in deltas, is the main point of my talk today. My first slide shows a representative sampling of delta, of about 40 well-characterized deltas, and shows the worldwide nature of the problem. The red points are the deltas that have been studied. The smaller yellow dots are upstream reservoirs, which play an important, another key role as a threat to deltas. That is the diversion of sediment, which feeds and maintains the deltas. And in some sense, we can essentially say the deltas are hemmed in by two key threats of a distant origin. There is, of course, the local questions about population and development. One distant threat are the reservoirs that starve them, and the other is the sea level rise that threatens to drown them. And I'll return to the consequences of these threats a little later, but I could not give a talk on this subject without mentioning other threats, and in particular, the Deepwater Horizon explosion in the Gulf of Mexico several months ago. And on the right, the left-hand panel shows you a satellite photograph with the bright spot at the lower right-hand corner being the infiltration of oil towards the wetlands of the delta. And then, of course, this is given a color enhancement, an artificial color enhancement in the right-hand photo where it's the black, oily-looking area at the lower right, which shows the oil headed towards the delta. Now, what forces maintain deltas? Why are they there in the first place? I'm going to focus on this from a scientific point of view. Number one, there's accretion of sediment. The rivers upstream naturally would be bringing sediment down into the deltas, and those essentially feed and maintain them. And that gets a plus sign because it raises their elevation. Number two is compaction of that sediment, which happens naturally, and number two, subsidence, which happens partly due to tectonic activity in the neighborhood of the deltas, and those generally lead to sinking or lowering of the elevations of the deltas. And the third is a small component of long-term sea level rise, which also has a negative contribution to the elevation of the deltas. But humans are altering each of those influences. Groundwater withdrawals and oil and gas withdrawals are adding a negative to the, essentially an extra subsidence. They're encouraging subsidence and reducing the altitude, the elevation of the deltas. Upstream impoundment and diversion of water